what is 32.6987 to two significant figures? Okay, we want to ensure that we know what this term here means. Significant figures. All right, significant figures, just remember, if we didn't start with 0, well, it doesn't even matter if we start with 0. The first digit from left to right, that's not a 0, is the first significant figure. After that, the zeros in between significant figures are significant. At the end of a decimal, where you have a point, at the end of the decimal, the zeros will be significant. But prior to meeting the first significant figure, the zeros aren't. So when I say prior to meeting the first significant figures, let's look at these numbers here. How many significant figures do you think there are there? 6 is correct. All right, so this is the first significant figure. These are just placeholders. Zeros at the end of a decimal number, right? In this case, when I say decimal, I mean ending after the point, yeah? The 0 here will be significant because it's at the end of the decimal number here. Zeros in between significant figures are significant themselves. So you have non-zero digits, or should I say zeros in between non-zero digits are significant. So we have these two zeros between 1 and 8, so they are significant. So counting, we have 1, 2, 3, 4, 5, 6 significant figures. All right, but let's look at the question at hand. We have 32.6987 to two significant figures. All right, the first significant figure is 3, the second is 2. So we have 1, 2, 3, 4, 5, 6 significant figures. The point doesn't change the fact that we have significant figures here. We only want 2 of them, so we're going to cut these off, and we're going to have 32. The question though is, do we add zeros at the end to maintain place value? Remember, we only put zeros to maintain place values, you know. If we look at this number here, it's 32.6987. These are the two significant figures, right? I didn't round properly, by the way. I should actually add 1 to the 3 because the very next digit afterwards is a 5 or more. We add 1, so this actually be 33. Okay, so we're looking at 33. The question is, look at this, the place value. The place value of this 3 is what? Remember, this is actually in the tens. This is in the ones position. So this is actually 3 tens, 2 ones, right? Then this is actually in the tens position. What's the place value of this 3? Also tens, right? So it did not change. So we don't have to add zeros at the end to maintain place value. So we'll leave it as 33. So our answer is actually D. Anything else is incorrect. If you look at these, this actually has 3 significant figures. This actually has 4 significant figures. 32 is because we didn't round the number up. So let's look at, well, of course, this is definitely wrong. So again, 33 is the correct answer, and this was selected incorrectly as the correct answer. Looking at this, a 3.0048 is approximately to 3.005. The approximation is a corrected 2. So in this case, did we use decimal places or significant figures? Did we use decimal places or significant figures to move from here to here? Well, let's see the options they gave us, because we can actually round to significant figures and decimal places, but depend on the options they gave us. All right, 2 significant figures. Well, we'll look at this. This is definitely not 2 significant figures. How will we know it's not? Because these zeros are in between 2 non-zero digits. 3 significant figures. This is definitely out of the way as well, because again, these zeros are significant because they are appear between 2 non-zero digits, and non-zero digits are always significant. So we have 4 significant figures. We don't have that here. So the answer is either 3 decimal places or 4 decimal places. If you look at this, decimal places are counted after the point, or the decimal point, right? So we have 1, 2, 3, and we stop at the other third decimal place. So based on this, if you look at this, after the decimal point, we have 1, 2, 3. So after the third 1, 2, 3, it's indicated we stopped, and we round this up because the digit after is greater than 4. Well, greater than 4 is 5 or more, and we added 1. So we added 1. All right, so that's actually rounded off to 1, 2, 3 decimal places. So this is the correct answer. Anything else is incorrect. Let's see if an incorrect answer was selected. If an incorrect answer was selected, then we can determine that yes, an incorrect answer was selected. The correct answer is 3 decimal places. Let's look at this. What do you think is the answer? You can pause the video and work it out. Well, they have the answer as 2. Let's check to make sure the answer is actually 2. All right, so we have this big square root symbol over everything. What this tells us is that we have to work everything underneath before we can find the square root of the number. So we want to make sure we figure out what number is underneath the square root symbol, the bigger one. So we have to work out that part. We need to work out what is this plus this. No, this is actually 6 squared and not 62. Bear in mind that 6 squared is 36. So the square root of 36 plus 10 squared is actually 100. And the square root of 36 is actually 6. And the square root of 100 is actually 10, which will give us 16. So in fact, we're trying to find the square root of this number underneath, which is actually 16. And that answer is square root of 16 is actually 4. So again, this answer was selected was incorrect. And our correct answer, so if we add 2, it's not correct. Our correct answer is B, which is actually is equal to 4. But we could have done this a different way. Once you have a square root symbol with a square, they cancel each other. One square root with square only, not cube root, not fourth root, must be a square root with square. Because we can think of a little square, a little 2 being there, call it square root, right? So the 2 square cancel square root. So we'd have 6 and 10 underneath, which is 16. So square root of 16, which is 4, which is our final answer.